Hey, welcome back. This is episode 22 of the Salesforce Agentforce Masterclass. Today, Agentforce Session State and Memory Architecture. How autonomous agents maintain conversation memory, session variables, and multi-turn context without bleeding tokens. Let's get into it. Here's what we're covering today. The Stateless LLM Paradox and Salesforce's stateful solution then, the Atlas State Manager, engine room of active context then, short-term RAM versus long-term CRM context storage then, designing session variables and secure input guardrails then, context pruning, and sliding window token optimization then, state serialization and interruption handling mechanics then, securing session state from memory poisoning attacks then, enterprise architecture best practices for memory management. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Today, we are diving deep into the literal brainstem of Agentforce, how it remembers what happened 5 turns ago without blowing up your token limits. It is all about session state, conversation memory architecture, and state-preserving variables.
I have always wondered about that. If LLMs are inherently stateless, how does Agentforce keep track of a complex customer refund process over a 20-minute chat without getting confused or leaking data?
Imagine trying to write a complex novel, but every time you turn the page, your memory is completely wiped clean. That is exactly how raw large language models operate, they are entirely stateless. Every single prompt sent to an LLM must contain the historical context of the conversation to make sense of the next question. In an enterprise setting, if your customer is chatting about a shipping delay, passing the entire transcript back and forth blindly will quickly deplete your token budget and introduce massive latency. Salesforce solves this by wrapping the LLM with an intelligent, sub-second state handling layer. At the center of Agentforce memory architecture sits the Atlas State Manager. Think of it as the high-speed cache of your agent's brain. When a user interacts with the agent, the State Manager intercepts the utterance, retrieves the current session state from secure key-value stores, and prepares the contextual payload. It does not just store plain text transcripts, it actively tracks active variables, metadata, execution logs, and the current topic slot filling progress. This allows the reasoning engine to understand not just what the user said, but exactly where they are in the business process. To design scalable agents, you must understand the difference between short-term session memory and long-term CRM data. Short-term memory is like transient RAM, it holds active variables like the current order ID or user mood indicator that only matter during the active session. Once the chat ends, this session RAM is flushed to maintain compliance. Long-term memory, on the other hand, is written directly to the CRM database, such as creating a case, updating a contact profile, or syncing to data cloud. As an architect, you must decide what transient data remains in cache and what persists globally. Session variables are your secret weapon for building hypercontextual agents. When an agent session starts, you can pre-populate these variables using system context, such as the logged-in user ID, the page the user is viewing, or their recent purchase history from Data Cloud. These variables act as absolute truth guardrails for the agent. For example, if we lock the variable account ID based on the logged-in user, the agent cannot be tricked by a prompt injection attack to retrieve or modify order records belonging to a completely different customer account. If a user has a long, rambling conversation with your agent, the raw chat transcript can quickly grow to tens of thousands of tokens. To prevent latency spikes and context window exhaustion, Agentforce utilizes advanced context pruning and sliding window techniques. Instead of passing the entire transcript word for word, the Atlas State Manager continuously summarizes older turns of the conversation. It keeps a highly detailed record of the last 3 turns, while condensing the older history into a compact bulleted summary, ensuring the agent retains context without carrying dead weight. In the real world, human conversations are messy and rarely linear. A customer might start asking about return policies, suddenly ask, by the way, what are your store hours, and then expect to seamlessly return to the return process. This is known as dialog interruption. Agentforce handles this using serialized state snapshots. When the user goes off topic, the agent preserves the active state of the original task in the background, spins up a temporary context for the side question, resolves it, and then cleanly deserializes the original state to pick up exactly where they left off. One of the most sophisticated attacks on autonomous agents is session memory poisoning. This happens when an attacker injects malicious instructions into conversational history or CRM fields, hoping the agent will execute them when reading past interactions. To defend against this, Agentforce enforces strict trust boundaries. The trust layer inspects incoming historical text for instruction injection patterns, sanitizes serialized state objects, and separates execute privilege actions from raw conversational text. This guarantees that your agent treats history as informational data, never as executable commands. To wrap up our architecture deep dive, let us outline the blueprint for deploying stateful agents in production. First, always initialize your agent with pre-grounded, immutable context via JWT-signed session variables to enforce bulletproof security. Second, design compact flow and apex actions that explicitly declare inputs and outputs, allowing the state manager to map variables cleanly. Finally, regularly monitor session metrics in your Agentforce dashboards, paying close attention to average turns per session and token usage patterns to identify context-heavy bottlenecks. Alright, let's wrap up. Here are the key things to remember. LLMs are stateless by default. Agentforce bridges this gap with the Stateful Atlas State Manager. Differentiate between short-term RAM variables and long-term CRM record updates to protect performance. Utilize context pruning and sliding window techniques to control token usage and prevent latency. Deploy secure input variables to prevent memory poisoning and context injection attacks. If this helped, hit like, it really helps the channel. Next up, AF_EP23_governance_performance. See you tomorrow.